I just want to talk about the perpendicular bisector. Now, the basic equation for the perpendicular bisector is z minus z1 in absolute value equals z minus z2 in absolute value. Because when you're looking at z minus z1 or z minus a complex number, so say we just had modulus of z minus a plus ib, what that actually means is the distance z is from the point AB. Okay, so when we're looking at that locus, if we're just doing it using vectors, if this was z1 here and this was z2 here, then this just means the distance that z is from z1 will equal the distance that z is from z2. So if we drew a line connecting these and we went right down the middle, the equation of the line that you want would be the perpendicular bisector of that line. Now, you could get it just using vectors, but if you were going to get it geometrically, you could just find the midpoint of z1 plus z2 on 2, and then you can get the gradient. Once you've got the midpoint, you have a point that it goes through. You get the gradient, because if you get the gradient of z1, z2, and then you find minus 1 over whatever that gradient is, and that would be the perpendicular gradient, and then just go y minus y1 equals mx minus x1. That's just one way of looking at it. You could get the actual equation as well, and you do that just by letting z equal x plus iy. So let's just look at a quick example here. So say we have z minus 1 equals z plus 3. So z plus 3 is z minus minus 3. So it just means that the distance from 1, that's the first one, will equal the distance from minus 3. So that means if you go halfway between 1 and minus 3, you end up with minus 2 on 2, which is minus 1. That means that the line, this line that we're talking about, would be x equals minus 1. Now, if you derived that from scratch, you'd let z equal x plus iy, and I just want to show you that it is actually x equals minus 1, and it is the perpendicular bisector of those 2 points there. So that means that you'd have x plus iy plus 3 equals x plus iy, so iy minus 1, sorry, the first one's minus 1, and x plus iy plus 3. Okay, that's what we've got there. So if you use the modulus, that would be x minus 1 plus y squared equals the square root of x plus 3 squared plus y squared. And if you square both sides, the square roots go out, and then expand this bracket, x squared minus 2x plus 1 plus y squared is x squared plus 6x plus 9 plus y squared. The y squareds go out, the x squareds go out. 1, if you take 1 away from that, you get 8. If you take 6 away from that, you get minus 8. 8 divided by minus 8 is just minus 1, which is what we require. Okay, so we're just going to look at another one that is the perpendicular bisector, but I'm just going to make it a little bit, if we wanted to sketch this one, and then we'll go plus 2 minus 2i. Okay, so if you wanted to sketch this, this is z minus 1 minus I, so take out the negative, and this is z minus 2 plus 2i. Okay, they're the same thing. So this point here is 1 minus 1, and this point here is minus 2, 2. So if you go 1 minus 1, that's there, and minus 2, 2, that's there. So if you want to find the line that is halfway between those 2 points, and then perpendicular to it. I mean, if you wanted to, you could add the x's together and divide by 2. You get it exactly. Add the x's together, divide by 2. So you actually get minus a half, don't you? So minus a half, so it's somewhere there. And then if you get a ruler, that would be what your line would look like. If you did want its actual equation, the Cartesian equation of that line, you could either just let z equal x plus iy and then derive it from scratch, like that. Iy using LOCUS plus 2 minus 2i, etc., because this would be x minus 1 plus i, y plus 1 equals x plus 2 plus I, y minus 2. So it's the square root of x minus 1 squared, y plus 1 squared equals the square root of x plus 2 squared plus y minus 2 squared. And then etc. And then you go ahead, square it out and simplify it. The other way of actually getting this is just to get, you've got the midpoint. So you get the midpoint, which is minus a half, and then you get the gradient between those 2 points. So you do 2 minus minus 1 over minus 2 minus 1. 3 on minus 3, you end up with minus 1. So the perpendicular gradient would be minus 1 over minus 1, so it would be 1. And then once you've got that, you just go y minus a half equals 1, x minus minus a half. So it's y minus a half equals x plus a half. Multiply throughout by 2. 2y minus 1 equals 2x plus 1. So that means that 2x minus 2y plus 2 equals 0. X minus y plus 1 equals 0. And that would be the equation of the line, which is the perpendicular bisector of these two, this one here, these 2 points, which is minus 1 and minus 2. So that one was just the locus of a line, which is the perpendicular bisector. If you wanted the locus of a circle, the basic equation is z minus z1 in absolute value equals r. So if you had z minus and you had a plus ib, so you had it of that form, which equals some number r, then the centre would be ab and the radius would be r. So if we've got, say, z minus 3 plus 4i equals 1, that means that when you're trying to sketch that, or even find the centre and the radius, it's z minus 3 minus 4i equals 1. So the centre would be 3 minus 4, and the radius would be the square root of 1, which is 1. So if you go 1, 2, 3, 1, 2, 3, 4, minus 4, which is there, radius 1, so you just draw a circle of radius 1. Now, just with locus involving arguments, so the basic one would be arg of z minus z1 equals theta. That just means that if this was z1, and we usually leave an open circle, I'll show you why in a minute, then the angle that we're looking at and the line we're looking at that's on that angle is this one here. And that angle would be theta. So if you look at this from scratch and you let z equal x plus iy and z1, just let that be a plus ib, then when you think about this, that would be the argument of x plus iy minus a plus ib, and that equals theta. So that argument, then we put the real parts together and the imaginary parts together, like theta, like that. Then that means that tan theta would be y minus b on x minus a. Now we know that x cannot equal a, otherwise the denominator would be 0. So it's when x minus a equals 0. So what this means here, if we think about this, that's y minus b on that side equals tan theta times x minus a. Now this looks exactly like this. Y minus y1 equals mx minus x1. And you might remember that the gradient of the line is tan theta. And this whole thing here, y minus y1, okay, that's the gradient point formula, because the point that this line goes through is a, b. Okay, so let's just look at one of these, and we're just going to sketch one of them. So we're going to have sketch arc of z plus 2 minus 2I equals minus pi on 4. Okay, so if we go to sketch this, basically we need to get the point first. So we go arc of z minus 2 plus 2I equals minus pi on 4. So the point is minus 2, 2. Okay, you put an open circle there, dot the line. Now because it's minus pi on 4, then basically that would be minus pi on 4. The angle theta will go in between pi, minus pi and pi. And basically in this quadrant, it's theta. This one's pi minus theta. This one's minus theta. And that one's minus pi minus theta. So it's like acute, obtuse, minus acute, and then minus obtuse coming around here.